66 million years ago, an asteroid ended the age of the dinosaurs. But what killed the Ice Age? It wasn't an asteroid, it wasn't a volcano, it wasn't a comet. It was something far stranger, far more silent, and it happened in just hours. Right now, I want you to picture the world 10,000 years ago. The planet looks nothing like it does today. A third of all land on Earth is buried under ice, sheets so thick, so massive, that their weight has pushed entire continents down by hundreds of meters. Woolly mammoths roam what will one day be France. Saber-toothed cats hunt across what will become the United States. Giant ground sloths, the size of elephants, lumber through South America. Humans exist, but they are few, scattered, cold, and surviving by the thinnest possible margin. And then, over the course of just hours, everything begins to change. Forever. To understand what happened in those hours, we need to understand the world they destroyed. We are in what scientists call the Younger Dryas, a brutal 1,000-year cold snap that had gripped the planet since approximately 12,000 years ago. Temperatures across Greenland were 10 degrees Celsius colder than today. In Europe, average temperatures had plummeted 5 degrees. Much of North America was simply uninhabitable. The ice sheets covering the northern hemisphere were not just large, they were civilization-ending in scale. The Laurentide ice sheet alone, which covered North America, was in places 3 kilometers thick. 3 kilometers. The height of 9 Empire State Buildings stacked on top of each other, made entirely of ice. Under these conditions, the megafauna of the Ice Age had adapted. The woolly mammoth had survived 12 previous ice ages. 12, without going extinct. Their thick, layered fur, their ability to dig through meters of snow to find buried grass, their massive size, which conserved body heat. The cave lion, the dire wolf, the short-faced bear, a predator that could look a modern grizzly in the eye while standing flat-footed and still be taller. These animals were not fragile. They were the most cold-adapted, most resilient creatures that had ever walked this planet. And they were all about to lose. Not to a predator, not to a disease, but to 3 days of weather. Here is what science tells us happened, reconstructed from Greenland ice cores, ancient pollen samples, deep sea sediment, and thousands of radiocarbon dates from around the world. The story begins not with a bang, but with a small, almost imperceptible shift in the ocean. There is a river beneath the Atlantic Ocean. You cannot see it from the surface. Most people have never heard of it, but it is the single most important mechanism regulating temperature on planet Earth. It is called the Atlantic Meridional Overturning Circulation, or AMOC. And for the past 10,000 years, through the entire Younger Dryas cold period, it has been barely functioning. Here is how it normally works. Warm tropical water flows north along the surface of the Atlantic toward Greenland. As it cools, it becomes saltier and denser. It sinks. Cold water flows back south along the ocean floor. And this giant conveyor belt of water carries enormous amounts of heat from the equator to the northern hemisphere, warming Europe and North America by as much as 5 to 10 degrees Celsius compared to what they otherwise would. But 12,000 years ago, something broke it. A catastrophic release of fresh water from a massive glacial lake, possibly Lake Agassiz, which at its peak was larger than all of today's Great Lakes combined, flooded into the North Atlantic. Fresh water does not sink. it floats, and it disrupted the entire salt balance of the AMOC, shutting it down almost completely. The result was the younger Dryas. Without the AMOC pumping warm water north, Europe and North America plunged back into near glacial cold. The ice came back. The megafauna endured. The world held its breath. For 1,200 years, the system was stuck, like a broken engine. All the right parts, just not enough energy to restart. And then, approximately 12,000 years ago, in a span of time scientists can now pinpoint to within decades, something changed in the ocean floor. The AMOC began to restart, slowly at first, then faster. Then, within what researchers now believe was less than 48 hours, a tipping point was crossed from which there was no return. In less than 3 days, the largest climate system on Earth flipped like a switch. How do we know this? Because we have the receipts, buried in the ice of Greenland. Beginning in the 70s, scientists drilled more than a kilometer down into the Greenland ice sheet and extracted ice cores, cylindrical samples of ice that preserve, layer by layer, a record of every year's atmosphere going back hundreds of thousands of years. Dust, oxygen isotopes, chemical signatures, all of it locked in ice year by year, like pages of a book. What those ice cores showed shocked the scientific world. The transition out of the younger Dryas, the end of the Ice Age, did not happen gradually. It did not take centuries. According to the ice cores, temperatures in Greenland rose by 12 degrees Celsius in approximately 50 years. And within that 50-year shift, there was a moment, a pivot, that appears to have happened within decades, possibly within days. When the AMOC begins to restart, the first thing that changes is not the land. It is not the ice. It is the sky above the North Atlantic Ocean. As warm water begins flooding north again for the first time in over 1,000 years, it makes contact with cold Arctic air sitting above the surface. The temperature differential is enormous. And when enormous temperature differentials meet moisture and movement, there is only one result: storms. Massive, relentless, unprecedented storms. Imagine standing in what is now Iceland, approximately 12 hours into the Great Transition. The sky to your south has changed color. It is no longer the flat, gray-white of a frozen world. It has turned a deep, bruised purple-green, the color of something alive, something enormous, something moving. The temperature, which has been stable and brutally cold for as long as anyone alive has known, begins to rise. Not quickly, not yet, but the wind shifts. For the first time in a generation, the wind is coming from the south, from the sea, and it is warm. Now imagine you are a woolly mammoth standing on the tundra of what will one day be northern France. You've survived every winter of your 40 years of life. Your species has survived 12 ice ages. You have eaten frozen grass, pushed through walls of snow, endured temperatures of minus 100 degrees Celsius. But something tonight is different. The air smells wrong. The ground beneath your enormous feet, ground that has been frozen solid for thousands of years, is making sounds. Low, deep, cracking sounds. The permafrost is beginning to shift. Here is something most people do not realize about permafrost. It is not just frozen ground. It is a structural element of the entire ecosystem. The trees grow in it. The rivers are shaped by it. The entire landscape depends on it being rigid. When permafrost begins to melt, even slightly, the landscape transforms almost overnight. Ground that was solid becomes soft. Ground that was flat begins to sag and slump into bizarre shapes, a phenomenon scientists today call thermokarst. Ancient ice within the soil melts into pools. Lakes appear from nowhere in hours. Methane, trapped for thousands of years, begins bubbling up through the newly softened ground. The ground itself is melting from the inside.
And the creatures that have spent thousands of years perfectly adapted to this frozen world are about to discover that their entire environment, their food, their shelter, their very landscape is dissolving beneath them. But right now, at hour 12, that process has only just begun. The real transformation is still coming, because the storm over the North Atlantic has not reached its peak, and the warm water now flooding north through the restarted AMOC is carrying energy, enormous amounts of energy. Energy that has been building for centuries, and in approximately 4 hours, it will make landfall. By hour 36, the warm air mass from the restarting Atlantic conveyor has pushed deep inland. The temperature across Greenland, which we can trace precisely from the ice cores, has already risen by 2 degrees Celsius in less than 2 days. That does not sound like much, but on a planet where the difference between an ice age and a warm period is only 5 to 6 degrees globally, 2 degrees in 36 hours is extraordinary. It is geologically instantaneous. At the southern edges of the great ice sheets, in what is now the British Isles, in northern Germany, across southern Scandinavia, the ice is beginning to melt.
To understand what happens when ice sheets melt, you need to understand just how much water they contain. The Laurentide ice sheet, covering North America, held approximately 34 million cubic kilometers of water. That is enough water, if spread evenly, to cover the entire surface of the Earth, every mountain, every valley, every ocean, to a depth of 66 meters. As the warming intensifies over the coming decades and centuries, this water will pour into the oceans. Sea levels will rise. But right now, at hour 36, what we are seeing is not global sea level rise. What we are seeing is something more immediate, more violent. We are seeing rivers, unprecedented rivers.
When a glacier melts at its edge, the water does not simply drain away politely. It carves, it rips, it tears through rock and soil with a violence that is difficult to comprehend. Glacial meltwater can carry boulders the size of cars. It strips topsoil from entire landscapes. It rewrites river systems in hours. What will eventually become the Thames, the Rhine, the Seine. These rivers are not trickling streams right now. They are roaring, sediment-choked, violent arteries of meltwater, carrying the weight of the dying ice sheet toward the sea. And living in the path of these rivers are the great herds of the Ice Age. Picture a herd of woolly rhinoceros, creatures that have grazed these frozen steppe grasslands for 200,000 years. They stand in a valley that has always been their winter feeding ground. The dried, frozen grasses here have sustained them through every cold season in memory. But today, the valley sounds different. There is a low, growing roar from the north. The ground is vibrating. And then, over the ridge, a wall of gray-brown water 10 meters high comes rolling toward them. A glacial outburst flood, carrying ice, boulders, and 1,000 years of accumulated debris. The herd runs. Some make it, some do not. But even those that escape the flood face something more insidious, something slower, and ultimately more lethal. Their food is disappearing. The Mammoth steppe, the vast grassland ecosystem that stretched from Spain to Siberia across the frozen north, was one of the most productive ecosystems that has ever existed. Cold, yes, but incredibly rich in the grasses, sedges, and herbs that sustained the great herds. As temperatures rise, this ecosystem does not simply warm up and flourish, it transforms. Cold-adapted grasses are replaced by shrubs. Shrubs are replaced by trees. The open steppe, the habitat that fed millions of large animals, begins to close in, to fragment, to disappear. And the animals that depend on it have nowhere to go.
By hour 60, something even more significant is happening. Something that will seal the fate of the Ice Age permanently. Scientists call it a positive feedback loop. And in the context of climate, positive does not mean good. It means self-reinforcing, a process that feeds itself and accelerates beyond any ability to stop it. Here is how it works. Ice is white. White surfaces reflect sunlight back into space rather than absorbing it. This is called albedo. A planet covered in ice reflects enormous amounts of solar energy, which is one reason ice ages stay cold. The ice reflects the heat away. But as the ice begins to melt, it exposes the dark ocean water beneath. Dark surfaces absorb sunlight rather than reflecting it, so the ocean heats up. Warm ocean melts more ice. More ice melts, exposing more dark ocean, which heats up more, which melts more ice, which exposes more ocean, which heats up more. At hour 60 of our 72-hour window, this albedo feedback loop has crossed its own tipping point. The warming is no longer being driven solely by the AMOC restart. It is now driving itself. Simultaneously, across the vast permafrost zones of Siberia and North America, something ancient and terrifying is waking up. Methane. For thousands of years, dead organic matter, the remains of ancient plants and animals, has been locked, frozen in the permafrost, unable to decompose. As the ground thaws, bacteria go to work on this material for the first time in millennia, and their waste product is methane, a greenhouse gas more than 80 times more potent than carbon dioxide over a 20-year period. The methane that begins releasing from the thawing permafrost at this moment will, over the coming centuries, amplify the warming still further. Another feedback loop, another engine firing up and running on its own. The climate system has become a machine that cannot be stopped. Not by anyone, not by anything. And what about the humans? Where are they in all of this? In 11,700 BCE, the total human population of Earth is estimated at somewhere between 1 and 5 million people. They are scattered across the globe in small groups, hunter-gatherers following the seasonal movements of animals, fishing rivers and coastlines, gathering plants in the warmer latitudes. They are not causing this change. They are not industrialized. They have no capacity to alter the climate. They are, like every other species on Earth at this moment, passengers, caught inside a planetary event they cannot understand and could not name. But here is the difference between the humans and the mammoths, between the humans and the saber-toothed cats and the giant ground sloths, between the humans and every other large mammal that will struggle to survive what is coming. Humans can change everything about themselves except their biology, their tools, their diet, their shelter construction, their social organization. their geographic range. They can live in deserts, in jungles, in Arctic conditions, on coastlines, in mountain valleys. They can eat almost anything. As the Ice Age world dissolves, the great specialized creatures of the Pleistocene, perfectly tuned to the frozen steppe, will find that their specialization has become their death sentence. They are too well adapted to what they are to become something else fast enough. The humans, by contrast, will simply begin to become something new. This wasn't just the end of an ice age, it was the dawn of a new era. The impact event, though devastating, inadvertently cleared the path for the Holocene, the geological epoch we live in today, characterized by a stable, warmer climate that allowed human civilization to flourish. The very ground beneath our feet, the fertile plains, the river valleys, all bear the scars and gifts of those 72 hours. It's a story of destruction, yes, but also of profound transformation, a testament to the planet's capacity for both violence and renewal. The last woolly mammoths will die approximately 4,000 years ago on a remote Arctic island called Wrangel Island, north of Siberia. Long after the pharaohs built the pyramids, long after Stonehenge was completed, they survived in their isolated refuge until almost within reach of written history, almost within reach of being remembered by name. The saber-toothed cat is gone. The cave lion is gone. The short-faced bear. The Irish elk with antlers spanning 4 meters. The giant ground sloth, the glyptodon, an armadillo the size of a Volkswagen Beetle. All gone. Not because they were weak. They endured conditions we cannot imagine for longer than human civilization has existed. They were undone by 72 hours of ocean chemistry. When scientists drill into the Greenland ice sheet today and pull up those ancient cores, they can see that moment. A thin layer of ice where the dust suddenly decreases, where the oxygen isotopes shift, where the chemistry of the atmosphere changes abruptly within what may be a single annual ice layer, a single year, preserved in ice. The year the Ice Age ended, the year our world began. If this story moved you, share it with someone who loves the deep history of our planet, and subscribe, because the next chapter of Earth's story is already waiting for you.